Floods, a catastrophic event of nature, possess the potential to inflict substantial devastation upon both human lives and essential infrastructure. These devastating occurrences transpire when an overwhelming volume of water surges, engulfs, and saturates areas that are conventionally arid, thus creating a state of aquatic domination. Although floods manifest themselves due to a multitude of reasons, they can be primarily classified into three distinctive categories: causes stemming from weather phenomena, human activities, and geographical factors. The amalgamation of these factors precipitates the occurrence of flooding, leading to the severe aftermath and consequences that accompany these natural calamities. Weather-related causes play a significant role in the occurrence of floods. Heavy rainfall is one of the crucial factors. When there is an excessive amount of rainfall within a short period, the ground becomes saturated, and the excess water accumulates on the surface. Inadequate drainage systems exacerbate the issue, preventing the water from efficiently flowing away. Additionally, storms such as hurricanes and typhoons can lead to severe flooding due to the intense precipitation they bring. Human activities play a significant role in intensifying the frequency and severity of floods. Various factors, including deforestation, urbanization, and inadequate land and water management, contribute to this undesirable consequence. Deforestation, in particular, jeopardizes the natural defenses of forests in controlling excess water. Trees, acting as guardians, possess the remarkable ability to absorb and retain rainwater, curbing runoff and maintaining a balanced water cycle. However, the relentless clearing of forests weakens this natural safeguard, making regions more susceptible to flooding events. Consequently, the disrupted balance between rainfall and the land's capacity to absorb it can result in heightened runoff levels, exacerbating flood occurrences. Thus, the implications of human activities on flooding span beyond mere recognition, demonstrating the intricate relationship between environmental preservation and disaster prevention. Urbanization, on the other hand, results in the replacement of permeable surfaces with impermeable ones, such as roads and buildings, which hinder water absorption. Improper land and water management, including the poor maintenance of drainage systems, can also contribute to floods. Geographical factors play a significant role in determining flood-prone areas. Low-lying and flat regions are more susceptible to flooding as water tends to accumulate in such areas. Coastal areas are also at risk due to storm surges caused by tropical cyclones or hurricanes. River valleys are particularly susceptible to flooding due to the combined effects of heavy rainfall and the melting of snow, which can lead to rivers exceeding their normal capacity and spilling over onto surrounding areas. In order to mitigate the risks associated with floods, it is imperative to implement a comprehensive strategy that encompasses both immediate and enduring solutions. Immediate measures involve the establishment and regular upkeep of robust drainage systems, as well as the construction of dikes and levees, which serve to regulate the water flow when faced with heavy precipitation. These short-term initiatives aim to swiftly address the pressing concerns brought by sudden downpours or rapid snowmelt. However, to truly safeguard river valleys from the perils of flooding, a long-term approach must be adopted. This involves implementing sustainable infrastructure projects, such as the creation of reservoirs and wetlands, to effectively manage water levels and improve overall flood resistance. By incorporating these dual strategies, communities residing in river valleys can enhance their resilience and establish protective measures that ensure the well-being of both their inhabitants and environment. Early warning systems and effective evacuation plans are crucial in saving lives and minimizing damages. Long-term measures involve strategic planning and management. For instance, preserving and restoring natural vegetation, such as forests, can enhance water absorption and reduce the risk of flooding. regulations can be put in place to control deforestation and ensure sustainable land use practices. Urban planning should prioritize the implementation of permeable surfaces, green infrastructure, and flood-resistant designs. Floodplain zoning, a vital land management strategy, can be effectively implemented to control and limit construction activities in areas that are prone to flooding and susceptible to its devastating consequences. By delineating specific zones within floodplains and imposing restrictions, this approach aims to safeguard lives, properties, and ecosystems from the perils of inundation. Furthermore, in order to enhance community preparedness and response to flood events, comprehensive education and awareness programs play a pivotal role. These initiatives serve to educate individuals and communities about the potential risks associated with floods, disseminate information on safety measures such as evacuation plans and emergency protocols, and highlight the crucial significance of community resilience and collective action in the face of adversity. By fostering a broader understanding of flood risks, these programs empower people to make informed decisions and take proactive measures to protect themselves and their surroundings. Shifting our focus to cyclones. These fierce and formidable atmospheric disturbances present a unique set of challenges. Marked by their intense and often destructive rotating winds, cyclones can wreak havoc on land and sea alike. Their development is fueled by a combination of warm ocean waters, atmospheric instability, and a distinct confluence of favorable meteorological conditions. With wind speeds exceeding 74 miles per hour, cyclones can result in torrential rainfall, storm surges, and significant structural damage. In order to mitigate the impacts of cyclones, it is crucial to implement robust early warning systems, emergency response protocols, and comprehensive disaster management plans. These measures aim to minimize loss of life, protect infrastructure, and ensure swift mobilization of resources for post-cyclone recovery efforts. By forecasting and tracking cyclones, meteorological agencies can issue timely advisories and alerts, enabling individuals, communities, and relevant authorities to take necessary precautions. In summary, through floodplain zoning, education programs, and proactive disaster preparedness measures, society can strive towards a more resilient future in the face of natural calamities such as floods and cyclones. These multifaceted approaches not only enhance safety and minimize the potential for loss, but also foster a sense of unity, shared responsibility, and collective action in safeguarding our communities and the natural environment from the impacts of these climatic events. Cyclones, also known as hurricanes or typhoons, typically form over warm ocean waters in regions near the equator. They occur due to a combination of factors, including warm ocean temperatures, low wind shear, and a large amount of moisture. Warm ocean temperatures are a key component in cyclone formation and intensification. As the ocean surface heats up, the warm air rises and forms clouds. This process releases heat, further fueling the cyclone. Low wind shear, which is defined as the disparity in wind velocity and orientation at various heights in the atmosphere, plays a crucial role in enabling a cyclone to sustain its coherent form and avoid disturbance. This phenomenon occurs when there is minimal interference from the vertical wind movement, allowing the cyclone's structure to remain intact. By exhibiting substantially low wind shear, the cyclone's powerful circulation can persist and maintain its intensity over time. Moreover, it is the presence of a considerable quantity of moisture within the atmosphere that provides the necessary fuel for the development of formidable thunderstorms within the cyclonic system. As warm and moist air rises, it cools and condenses, generating convective activity. This process facilitates the formation of towering thunderstorm clouds, characterized by intense updrafts and torrential rainfall. Consequently, this abundance of atmospheric moisture contributes to the cyclone's overall strength and the potential for destructive weather phenomena, while it is not feasible to entirely prevent the occurrence of cyclones. It is of utmost importance to implement measures that mitigate their impact and safeguard human lives and property. These measures encompass a comprehensive approach, including advanced forecasting techniques, efficient evacuation plans, robust infrastructure design, and widespread awareness campaigns. By proactively preparing for cyclones and minimizing vulnerability, communities and authorities can effectively reduce the devastating consequences associated with these natural disasters. Recognizing that cyclones are formidable forces of nature, it is imperative to acknowledge the necessity of continuous research and technological advancements in understanding their behavior. By delving deeper into the intricacies of these atmospheric disturbances, scientists and meteorologists can refine prediction models and enhance early warning systems. This knowledge empowers authorities to make informed decisions and mobilize resources promptly, thereby saving lives and minimizing damage. In conclusion, the interplay between low wind shear and an abundant moisture supply holds significant implications for the development and impact of cyclones. These natural phenomena are complex and dynamic, influenced by numerous factors that scientists are persistently studying. By expanding our understanding and taking proactive measures, we can mitigate the devastating effects of cyclones, preserving both lives and property in vulnerable regions. Early warning systems, satellite monitoring, and meteorological forecasting can provide valuable information about the formation and movement of cyclones, allowing communities to prepare and evacuate if necessary. Building structures that are resilient to high winds and flooding, such as reinforced shelters and elevated buildings, can provide protection during cyclones. In conclusion, floods and cyclones are natural disasters that can cause significant devastation. While it is impossible to prevent them entirely, understanding the causes and implementing appropriate measures can help minimize their impact. Effective land and water management, early warning systems, and resilient infrastructure are crucial in protecting communities and improving overall disaster preparedness and response.